Most people think that if they want to reduce their risk of type 2 diabetes, lose weight or improve their blood sugar, they simply need to eat less sugar, exercise more and lose some body fat. While those things are undoubtedly important, they may not be telling the whole story. Because over the last few decades, researchers have discovered something that many people would never consider. The amount of sleep you get each night may influence how well your body controls blood sugar. In other words, poor sleep may make your body handle food differently. Even before your diet changes. That sounds surprising because sleep and blood sugar seem completely different things. One happens while you're unconscious, the other depends on what you eat. But the human body doesn't separate these systems in the way we often do. Sleep affects the brain. The brain influences hormones. Hormones affect metabolism, and metabolism determines how effectively your body uses the food you eat. In this video, I want to explore 5 simple questions. What is blood glucose? What does insulin actually do? Can poor sleep make the body less sensitive to insulin? What does scientific evidence tell us? And finally, what practical steps can we take to improve our metabolic health through better sleep? I am Yon Figures, and I'd like to thank you for taking time to watch this video. If you enjoy the content, find it useful, or think it may help somebody else, consider hitting the like button, subscribing to the channel, and sharing it with someone who may benefit from it. Before we look at the research, we first need to understand a few important terms, because words like glucose, insulin resistance are often used without being properly explained. Let's start with glucose. Glucose is simply a type of sugar. It is the body's preferred source of energy. Whenever you eat foods containing carbohydrates, whether that's bread, rice, pasta, fruit, potatoes or sweets, your digestive system breaks much of that food down into glucose. That glucose then enters the bloodstream. Your blood carries it around the body so your muscles, organs and brain have access to fuel. But glucose cannot simply leave the bloodstream whenever it wants. It needs help entering most of your body's cells. That help comes from a hormone called insulin. Insulin is produced by the pancreas, an organ that sits just behind your stomach. Whenever blood glucose begins to rise after a meal, the pancreas releases insulin into the bloodstream. A simple way to think about insulin is a key. It unlocks the door of many of your body's cells, allowing glucose to move from the bloodstream into the cells where it can be used for energy or stored for later use. When the system works well, the blood glucose rises after eating. Insulin is released, glucose enters the cells, and blood sugar gradually returns to normal. The problems begin when the body's cells stop responding to insulin as effectively as they should. This is known as insulin resistance. Insulin resistance does not mean your body has stopped making insulin. In fact, during the early stages, your pancreas often produces even more insulin than normal. The problem is that the cells have become less responsive to insulin signals. Imagine someone repeatedly knocking on a door. At first, the person inside answers immediately, but after countless knocks, they become slower to respond. Eventually, they may barely react at all. The pancreas responds by knocking louder. It produces even more insulin to keep the blood sugar under control. For a while, this extra insulin is often enough. Blood glucose may remain completely normal. A routine blood test may even suggest everything is fine, but beneath the surface, the blood is working much harder to achieve the same results. Years later, the pancreas may struggle to keep up with demand. Blood glucose begins to rise. Prediabetes may develop. Eventually, for some people, type 2 diabetes follows. This is why insulin resistance matters. It often develops long before someone is diagnosed with diabetes, and researchers have been asking an important question. Could poor sleep be one of the factors that makes the body's cells less responsive to insulin? At first, many scientists were skeptical. After all, If someone eats the same food, exercises the same amount, and maintains the same body weight, why would simply sleeping less change how the body handles glucose? The answer appears to lie in the complex relationship between sleep, hormones, and metabolism. Sleep is not simply a period of rest. As we discussed in a previous video, sleep is an active biological process. While we sleep, hormones are released, tissues are repaired, memories are consolidated, and countless systems throughout the body are regulated. Metabolism is one of those systems. Researchers began to suspect that if sleep helps regulate hormones, perhaps reducing sleep might also interfere with hormones involved in blood sugar control. To test this idea, they needed carefully controlled laboratory studies where they could manipulate sleep while keeping everything else as constant as possible. One of the landmark studies in this field was established in The Lancet in 1999 by Ivan Kauter, Corinne Spiegel and colleagues. The researchers recruited healthy young men with no history of diabetes or major metabolic disease. This was important because they wanted to see whether sleep deprivation alone could alter glucose regulation without the confounding effects of obesity, aging, or chronic illness. The participants first spent several nights sleeping normally to establish a healthy baseline. They then entered a period where their time in bed was restricted to just 4 hours per night for 6 consecutive nights. During the study, food intake, physical activity, and laboratory conditions were carefully controlled. The researchers repeatedly measured blood glucose, insulin response, and glucose tolerance. Before we look at the findings, it's worth explaining one more important term: glucose tolerance. Glucose tolerance refers to how effectively your body deals with a rise in blood sugar after consuming glucose. If someone has good glucose tolerance, their body rapidly releases insulin. Glucose enters the cells efficiently, and the blood sugar returns towards normal relatively quickly. Poor glucose tolerance means the body struggles to control that rise. Blood sugar remains elevated for longer because glucose is not being handled as effectively. The results surprised many researchers. After just 6 nights of restricted sleep, the participants showed significantly poorer glucose tolerance. Their bodies were less effective at processing glucose than they had been after a normal sleep. They also showed changes in insulin response, suggesting their metabolism had become less efficient despite no change in body weight. Perhaps the most striking conclusion came from the researchers themselves. They suggested that the metabolic change observed after only 6 nights of sleep restriction resembled changes normally associated with aging. In other words, a single week of severe sleep deprivation temporarily shifted the body's metabolic function in an unhealthy direction. Now, this does not mean that 1 week of poor sleep gives you diabetes. That would be an enormous overstatement, and is not what the study found. The participants were healthy. The changes were measured under controlled laboratory conditions, and the study was designed to investigate short-term physiological responses, not diagnose disease. But it did demonstrate something extremely important. Sleep was not simply affecting how tired the participants felt, it was changing how their bodies handled glucose. That finding helped change the direction of sleep research. Scientists could no longer think about sleep purely in terms of fatigue or mental performance. Sleep was beginning to look like an important regulator of metabolic health as well. And if just 6 nights of restricted sleep could measurably reduce glucose tolerance in healthy young adults, researchers began asking an even bigger question. What happens when poor sleep continues for months or even years? One laboratory study is interesting, but by itself it is never enough to establish a scientific conclusion. Good science looks for consistency. If researchers in different countries using different groups of people and different study designs keep arriving at similar findings, our confidence in the evidence becomes much stronger. And that is exactly what begins to happen. One of the most influential studies to follow came from the University of Chicago and was published in the Annals of Internal Medicine in 2004 by Dr. Ivan Kauter and colleagues. including Dr. Kristen Knudsen. This study asked a slightly different question. Instead of restricting sleep for almost a week, what would happen if healthy young adults simply experienced several nights of moderate sleep restriction, like what many people experience during a busy working week? The researchers recruited healthy young adults with no obesity, diabetes, or significant medical conditions. The participants initially slept for 4 nights with approximately 8.5 hours in bed. They then spent 6 consecutive nights restricted to just 4.5 hours in bed. Food intake and physical activity were carefully controlled throughout the study, allowing the researchers to isolate the effects of reduced sleep as much as possible. At the end of each phase, the participants underwent glucose tolerance testing and insulin sensitivity was measured. Insulin sensitivity is simply the opposite of insulin resistance. If you are insulin sensitive, your body's cells respond well to insulin, meaning only a small amount of insulin is needed to move glucose into the cells. If insulin sensitivity falls, the body must release more insulin to achieve the same effect. The findings were striking. After less than 1 week of restricted sleep, insulin sensitivity had fallen by around 30%. In practical terms, the participants' bodies had become significantly less efficient at responding to insulin despite no changes to their weight overall. Again, this does not mean they suddenly became diabetic. Their bodies were still functioning, but they were functioning less efficiently than they had been after adequate sleep. This is important because many people assume that insulin resistance develops only after years of poor diet or obesity. Those are certainly major contributors, but this study suggested that sleep itself may influence insulin sensitivity over a surprisingly short period of time. Now let's think about what this means in everyday life. Imagine 2 identical people. They eat similar meals. They exercise the same amount. They have similar body weight, similar genetics. The only major difference is that one consistently sleeps 7.5 to 8 hours per night, while the other regularly sleeps 4.5 to 5 hours. These studies suggest that the person sleeping less may begin each day at a metabolic disadvantage before they've even eaten breakfast. Their pancreas may have to work harder. Their insulin may have to work harder. Their body may become less efficient at controlling blood glucose. That does not guarantee disease, but it does increase concern that chronic sleep restriction may slowly contribute to metabolic dysfunction over time. Scientists also looked beyond laboratory experiments to see whether these findings are reflective in large populations living normal lives. One of the most important pieces of evidence comes from a systematic review and meta-analysis published in Sleep Medicine Reviews by Capuccio and colleagues in 2010. Before explaining the findings, it's worth defining another scientific term. A systematic review is not a new experiment. Instead, researchers carefully collect all the available high-quality studies on a particular question, assess their quality, and summarize the evidence. A meta-analysis then combines the results statistically, allowing researchers to analyze data from hundreds of thousands of participants, rather than a few dozen volunteers. Because they combine many independent studies, systematic reviews and meta-analyses are often considered among the strongest forms of scientific evidence available. The researchers analysed data for more than 480,000 participants across multiple countries. They examined whether habitual sleep duration was associated with the future development of type 2 diabetes. The findings showed a remarkably consistent pattern. People who regularly slept fewer than 6 hours per night had a significantly higher risk of developing type 2 diabetes compared with those sleeping around 7 to 8 hours. Interestingly, the researchers also found that very long sleep durations were associated with increased risk, producing what scientists often describe as a U-shaped relationship. In other words, both unusually short and unusually long sleep appeared to be associated with poorer metabolic outcomes. This is an important distinction. The review does not prove that short sleep directly causes diabetes. Observational studies cannot establish cause and effect on their own. People who sleep less may also experience more stress, work night shifts, have poorer diets, or suffer from medical conditions that affect both sleep and diabetes risk. But when these population studies are considered alongside carefully controlled laboratory experiments, a much clearer picture begins to emerge. The laboratory studies demonstrate that reducing sleep can rapidly impair glucose regulation and insulin sensitivity under controlled conditions. The population studies show that people who consistently sleep too little are more likely to develop type 2 diabetes over many years. Taken together, the evidence becomes increasingly persuasive that sleep is not simply associated with metabolic health. It may be one of the biological processes helping to regulate it. But this raises another important question. Why would sleeping less make the body less responsive to insulin in the first place? To answer that, we need to look at what sleep deprivation does to the hormones that regulate appetite, stress, and metabolism. Those hormonal changes may explain why poor sleep not only affects blood sugar, but also makes many people feel hungrier, crave more calorie-dense foods, and find it harder to maintain a healthy weight. And that is where the story becomes even more interesting. But why would sleeping less make someone hungrier, less able to control their blood sugar, or more likely to develop insulin resistance over time? The answer appears to involve several hormones that help regulate appetite, stress, and metabolism. Hormones are chemical messengers. They travel through the bloodstream, carrying instructions from one part of the body to another. When sleep is restricted, several of these messengers begin behaving differently. One of the best known examples involving two hormones called leptin and ghrelin. Leptin is often referred to as the satiety hormone. It helps tell your brain that you have eaten enough and that your body's energy needs have been met. Ghrelin does almost the opposite. It is sometimes called the hunger hormone because it stimulates appetite, encourages you to seek food. Researchers have found that sleep restriction can reduce leptin while increasing ghrelin. In simple terms, poor sleep may leave you feeling less satisfied after eating while simultaneously making you feel hungrier. If you've ever craved sugary foods after a poor night's sleep or found yourself reaching for snacks despite having eaten recently, you'll experience something many researchers believe have a biological basis rather than simply being a lack of willpower. But appetite is only part of the story. Sleep restriction also appears to affect cortisol. Cortisol is often called the stress hormone, although it performs many important functions throughout the body. Under normal circumstances, cortisol follows a daily rhythm. It rises in the morning to help us wake up and gradually falls throughout the day. Chronic sleep deprivation can disrupt this rhythm, leading to higher cortisol levels at the times when they would normally be lower. Persistently elevated cortisol may contribute to increased blood glucose because one of the cortisol's jobs is to ensure the body has sufficient fuel available during times of stress. In small amounts, this is helpful. When chronically elevated, however, it may contribute to poorer metabolic health. When researchers put all of these pieces together, a pattern begins to emerge. Poorer sleep can reduce insulin sensitivity. Poorer sleep can alter hunger hormones. Poorer sleep can increase stress hormones. Poorer sleep can make higher calorie foods feel more rewarding. And poorer sleep often leaves people feeling too tired to exercise or prepare healthier meals. None of these changes alone guarantees weight gain or diabetes, but together they may create an environment where maintaining good metabolic health becomes much harder. This is one of the reasons I dislike the idea that people simply need more discipline. Of course, personal responsibility matters. We all make choices, but biology also matters. If someone consistently sleeps poorly, their body may literally be making healthier decisions more difficult. They may feel hungrier. They may crave calorie-dense foods. Their insulin may become less effective. Their stress hormones may be elevated. They may have less energy to exercise. Understanding this does not remove the responsibility, but it does remind us that human behavior is influenced by biology as well as choice. Now, it is important to keep these findings in perspective. One poor night's sleep is not going to give you diabetes. 1 week of disrupted sleep because a newborn baby, exams, or shift work does not mean permanent metabolic damage has occurred. The human body is remarkably resilient. It is designed to cope with occasional periods of stress. The concern arises when poor sleep becomes the norm rather than the exception. Night after night, week after week, month after month, year after year. This is also why improving sleep should not be viewed as a replacement for eating well or exercising. It should be viewed as another tool. Good nutrition matters. Physical activity matters. Maintaining a healthy body weight matters. But sleep deserves a place alongside them rather than beneath them. Too often we treat sleep as the first thing to sacrifice when life becomes busy. We stay up later to work. We wake earlier in exercise. We scroll on our phones long after we should have gone to bed. Then we wonder why controlling our appetite feels so difficult the next day. Perhaps one of the healthiest things we can do is stop thinking of sleep as time we lose and start thinking of it as an investment in the quality of every waking hour that follows. What practical steps can we take? The first is consistency. Going to bed and waking up at roughly the same time each day helps support your body's internal clock. The second is giving yourself enough opportunity to sleep. Most adults require around 7 to 9 hours each night, although individual needs vary. The third is reducing things that interfere with sleep quality, such as late caffeine, excessive alcohol, heavy meals immediately before bed, and prolonged exposure to bright screens late at night. Morning daylight exposure, regular physical activity, and keeping the bedroom cool, dark, and quiet can also help improve sleep quality. None of these habits is a miracle cure on its own, but together they create an environment where healthy sleep becomes more likely. Now let's bring all of this together. Poor sleep appears to affect blood sugar because it reduces insulin sensitivity, meaning the body's cells become less responsive to insulin. Sleep restriction has been shown in carefully controlled laboratory studies to impair glucose tolerance, making it harder for the body to regulate blood sugar after eating. Poor sleep also alters important hormones involved in appetite regulation, reducing leptin while increasing ghrelin, which may leave people feeling hungrier and less satisfied after meals. Sleep deprivation can also influence cortisol, potentially making blood glucose regulation even more challenging. Large population studies have found that people who consistently sleep too little are more likely to develop type 2 diabetes, although sleep is only one factor among many, and these studies cannot prove direct cause and effect. That is an important collection of findings because many people think of diabetes purely as a disease of sugar consumption. Diet undoubtedly plays a major role. Obesity undoubtedly plays a major role. Physical inactivity undoubtedly plays a major role, but sleep appears to be another important piece of the puzzle. The quality of your sleep may influence how effectively your body handles the food you eat the following day. If you care about maintaining healthy blood sugar, sleep matters. If you care about reducing your risk of insulin resistance, sleep matters. If you care about controlling your appetite, sleep matters. If you care about maintaining a healthy body weight, sleep matters. Sleep is not the only answer, but it may make every other healthy habit easier to sustain. The simple message is this: sleep is not just recovery for the brain, it is recovery for your metabolism too. While you sleep, your body is doing far more than resting. It is regulating hormones, maintaining insulin sensitivity, and preparing your metabolism for the day ahead. Sleep properly. You get one body. Fuel it properly.